This is problem number 14 on exam 2 review, and here you're given some properties of the graph of f of x and you need to sketch one. Again, my sketching doesn't come out too well in this program, so I just sketched one. I think the easiest thing to do would probably just be to paste it right here and just kind of talk about why it looks the way it does. So f is continuous from negative infinity to 3, from negative 3 to 7, and from 7 to infinity. Now you can look here and notice that this graph is continuous. Here at 3 it's got a vertical asymptote, and here at 7 it's got a hole. And the reasons for that is I'll draw those in see, I think I tell you, no, I don't tell you that 3 is a vertical asymptote, but notice here the limit as x goes to 3 from the left of f of x is negative infinity, and when it goes from the right it's positive infinity. So that implies that I have a vertical asymptote, and that's why I drew that there. The limit as x goes to 7 of f of x is 5. That's something to kind of clue in on. The fact that somebody told you a limit and not an f of x value at 7 tells you that I don't really know that there's a point here, and in fact there's not. There's a hole. That's all I can say about it, so I put that one on there. Let's see, what's the next one? The limit as x goes to negative infinity of f of x is negative infinity. That's why I actually, when I was drawing these, put these little arrows right here, because but I knew that's why it's going to negative infinity and positive infinity when we go to positive infinity. F prime of 1 is 0. Well, that means that I have a horizontal tangent line of f at 1, so I actually put those on the graph first. And f prime of 5 is 0. That also means I have a horizontal tangent line, meaning I have a relative max or min there. And then I said f prime is greater than 0 if x is less than 1 or x is greater than 5, which means that if f prime is greater than 0, then f is increasing. So you notice I have it increasing from negative infinity to positive 1, and it's increasing from 5 to positive infinity. F prime of x is less than 0 if x is between 1 and 3, or between 3 and 5, which if it's less than 0, that implies that f is decreasing. So between 1 and 3 I have the graph decreasing, and between 3 and 5 I have it decreasing. And then let's see, f double prime is less than 0 if x is less than 3, says that the f is concave down. So see, I have this downward concavity here in f, and then f prime of x is greater than 0 if x is greater than 3, means it's concave up. So I have this concave up here. And notice I didn't list the concavity or the increasing decreasing of f. This is all in terms of f prime and f double prime. If I had, I would have had to include these holes, this whole issue here, but I don't know if anyone knows this or we talked about it, but a hole will be a removable discontinuity. And if you have a removable discontinuity and you take the derivative, that the discontinuity generally, not always, but generally with like a rational function, which is the quotient of two polynomials, that factor that's causing that hole, well, you have an equivalent derivative as long as x doesn't equal 1. So that's kind of a, I don't know, I could have added that detail right there, as long as x doesn't equal 7 or something. But anyway, this is the one I got. And then finally, the range of f is from negative infinity to 1 and from 4 to infinity. That's where I get this gap right here. And in fact, I kind of programmed in, it's supposed to be a slant asymptote, although you wouldn't know that because you don't have the, and I didn't write this from a formula, I just made it up, but I kind of wanted a slant asymptote in there. Even though it didn't show up really well in my picture, it's supposed to be right there. But anyway, that's why I know that this is a f prime of 1 is a max, and f prime of 5 is a min, or f of 1 is a max and f of 1 is a min rather. So I think you should be able to look at this graph and look at these details and kind of figure this out for yourself, and hopefully the explanation is helpful. But I really think this is kind of one of those things you need to sit with. And I have several videos on YouTube where we kind of piece things together like this. I did like function summaries, and where we actually find all this stuff and then put it on the graph. And I think you should be okay.